I'm Daniela. First, something about me. I'm a physicist, and I work for Spazio Dati, like some other speakers you probably heard already. We are a company based in Trento and Pisa, and what we do is we handle data, as probably you could have already imagined. Data about companies in particular, we collect it from several sources, then we match it, and we basically make sense of it, and then we sell it. That's what we do. I want to talk to you about AWS Athena. That is a tool that I really love. First of all, what is it? What is Athena, besides a Greek goddess, obviously? Well, Athena is an AWS tool. AWS, do you already, everyone know what AWS is? Yes? Everyone. Okay, cool. So, basically what it does, it allows you to read from S3 files and to be able to query with the SQL language as if they were tables. Yes, since I really love buzzwords, I'm going to say all of them in one talk, so brace yourselves. It's serverless, and it also scales by itself, which means that basically no matter what kind of query you do, what kind of file you give it, how big it is, it will still respond in reasonable time because it automatically allocates the right amount of resources for you. And last but not least, it's cheap. It's really cheap. I'm not going to say exactly how cheap, but you are billed by terabyte of data that you actually read. So it's cheap. So what's our use case? How did we come across it? And why is it right for this particular situation and maybe yours too? So I already mentioned we handle data about companies. This data sometimes comes from the web, which means we have to do web crawling. Web crawling involves basically reading all the websites and then downloading the contents and use them for, well, machine learning, another buzzword. So in the end, we find ourselves with these huge lists of URLs that we crawled. And sometimes we want to know, I don't know, maybe you want to make sure that a particular URL we want to be freshly crawled all the time is there, or any other kind of monitoring. So we basically just need to do some counts usually, or just searching for something in particular. It's nothing really fancy, but still, we need to do it. And this data set is a really strange kind of data set because it's not only big data, but also it keeps growing. Potentially it never stops because every new URL you crawl will go in there. So you can see the problem. So you need to monitor this data set, which is really big. And also, you don't want to grow old waiting for a response when you do this. So what do? There are some alternatives, of course, of which some we tried. Not all of them. And I'm not trying to convert you to Athena religion and tell you it's the best thing ever, but maybe it could work for you the same way it worked for me. First of all, we tried Spark. We have this cluster that allows to do query in a distributed way. So how many of you use Spark or know what it is? What about PySpark? Okay, it's basically Spark, but you can use Python. But there are some issues here. First of all, Well, it's a cluster that you use for something that is really specific. So maybe you don't want to have it up and running all the time because that would be expensive. But at the same time, you can't wait, or every time you want to do a query, oh, let me just bring up my Spark cluster. That won't work. And also, how many of you would be able to bring up your own Spark cluster? Okay, exactly. So that's another issue. Uh, I'm speaking for myself. I mean, it's not the easiest thing ever. So you can learn to do it, but maybe you don't have the time to learn it. Maybe you don't want to, I don't know. Then you also have to maintain it. You have to make sure it actually works all the time. Also, you have to move data there. You have to put the data from wherever it is to Spark's RDD. So that's something else. So this solution can work, but it's not very good, in my opinion. So of course, there's the obvious solution. There's a PostgreSDB. This seems like your typical use case. You have a lot of data. You just basically need to put it somewhere, and sometimes you want to look at it. Why not use just Postgres and be done with it? Well, that's the growing old waiting for response I was mentioning. I mean, Postgres is not very good when you are dealing with really, really, really big data. In our case, the smallest possible version of this data set was 200 million lines. And it was really slow. I wanted to do some live queries, and I didn't want to wait half an hour for a group by. So this also didn't work very well. So should you use Athena? Well, I don't know. But if you have very big files that you are not really sure how to handle, maybe you know how to handle them, but you're not very satisfied with that way, well, just try it, because it really works, batteries included. So how do you input, okay. So how do you input data in Athena? Well, there are, of course. So this was supposed to be the previous slide. How does it work? Basically, what Athena does, it creates virtual tables from S3 files. Basically, under the hood, it's Presto, but it's already been deployed for you, so you don't have to take care of it. Presto is a distributed SQL query system, so it does what I was mentioning. It allocates the right amount of resources based on your query. How you can access your data? There are two ways, three actually. One is the interactive dashboard. You just go into your AWS console. I don't want to explain you how it works. You can figure it out. Then there are JDBC drivers. So you can basically treat it just like any other database, just like a regular Postgres. So whatever you do to connect with Postgres, you can do it. You can connect it to your favorite SQL editor, like I connected to my data grip. You can use my SQL Workbench or whatever. You can also connect it to a visualization tool, like Superset, for example. And you can create your dashboard that directly reads from Athena. And then, of course, you connect to Python. You can do it both through the JDBC driver with this library called PyAthena JDBC, and also through the API through the library PyAthena. I will do a little demo after on this. So how do you input data? Here's the missing slide. So how do you input your data? How do you tell it where to go and read? Well, you can just use the wizard. Just go to the dashboard I was mentioning and click on Add Table. It will ask you the path, where it should read from, and what columns are there, what type they are, these kind of things. And it's really easy. Or you can write your own creation query. This, I mean, I would advise that you try this because yes, the wizard is really useful, but whenever you are in a non-standard situation, maybe you have a file that is not included in the standard file types that it reads. There are several, but maybe it's not one of them. You might have to use a plugin, and this you can only do if you write your own script. But it's really super easy because if you only do one import from the wizard, then you can visualize the script and you just copy it and change whatever you need. So it's easy and you should try. And if you are either using the wizard or writing manually, use partitions. Partitions are in general, even in a regular database, basically allow you to see what logically is a huge table as a collection of smaller ones based on one column or more. Basically, why should you do it? Because, or why people usually do this? Because it's so much easier to add and remove stuff. You don't have to do expensive selection queries and filter on a date, for example. People usually are resorting to this when they have to add maybe new data every day, or anyway, on a timeline. This is very useful in Athena as well, because it becomes very, very easy to make your table in Athena update whenever you put a new file on S3. In this case as well, you can go the automatic way or the manual way, and I'll show you both of them. So automatic partitions are actually super easy to do. You just name your S3 folders, so your path of the files that you want to read. You name them, putting whatever the value you want to be defining the split. For example, as you can see, you can put the year, month, and day if you want to split in a nested way by date, or just the whole date in any format you like. This is just the string way. And then when you create the table, you just put that line and you tell it that it should be partitioned by a column named date. And then it will just go and see that there is date equals something different in each folder, and it will do it automatically. And then you just run the command for loading partitions that you can clearly see on the right side. It's a very simple command, and if you are using the wizard, it's just a button. You click on it, and it will load the partitions for you. Then you can go the manual way. You just run an alter table query specifying the new column that you want to partition on and the name of the file. This is, it works, and it's very good if you want to try partitions but I would advise against using it on a regular basis, because if the purpose of all this partitioning is to automatically load new files, it's so much simpler to just modify the path of S3 files. You can even use Lambda functions for it. Another buzzword for you. This is an example just of what the alter table query would look like. But you can find a nice guide on this too. So, okay, demo time. Hope this works. So I'll assume Wi-Fi is working. Okay. So what I do is just I import Athena connect. Then I instantiate my connection and I query. This is from one of those crawl DBs are called, so where all the crawled URLs are stored. I just queried for 10 URLs. This is how big the table is, so you can see I'm for real. Okay, so it's roughly 560 million rows. You can also use pandas with the regular SQL integration, and instead of passing it a connection to a SQL database, you just pass it the connection that you initialized with Athena. It's really very straightforward. Let's do a count. This is a different table with more interesting information. It should have about 300 million lines. You can search for URLs with a selected string and try to imagine how long it would take on a Postgres database for this query to run. It was 8 seconds. In 8 seconds, it told me exactly how many URLs I have that have pycon.it in them. So this is my personal example. This query used to take 45 minutes in Postgres. It takes a little bit longer than the other one. Okay, so 9 seconds. This is how much faster it is. This is a query that basically counts for each domain through a regex, so it's pretty expensive. By domain, how many URLs I have. So most of them have 1. This is just a simple count distribution. And this is it. This is what you can do. Thank you. These are my contacts. This is Spazio website. This is my Telegram and my LinkedIn. You can contact me if you want to talk about Athena.
Thank you, Daniela. Very interesting. There's any question from the public? Okay. Wow. We have time, so we're going to...
Okay, hi. We use in my company Presto instead of Athena, but actually it's the same query engine. I want to know, since you said that this is auto-scale, can you see how much worker node it's using the query? There's a way? Because with Presto we have the dashboard.
No.
You connecting to localhost? No. You are not able to access?
No, okay. You just read the result.
Okay, thank you.
You can know how much data it's scanned, because so you can imagine how much you're spending. That's it.
The data can only be modified by uploading new files to S3. Is that correct? Or is there any other way?
The what? Sorry?
The data can only be
The
modified by uploading new files to S3, or is there another way?
Uploading or deleting.
Yeah, okay. Some more elaborate question. I don't know if you're familiar with Apache Drill. We're using Apache Drill at our company, querying Parquet files, which are stored in S3, which are downloaded locally on a locally running drill machine. Do you have any idea how fast or slow Athena is in comparison? No.
I wouldn't know.
Have to have my own test then.
For this size of dataset, how much are you paying and what is the pricing model?
Okay, so the pricing is $5 per terabyte that you scan. So basically, if you scan and you query for, you make a filter or you only want one column, it will only charge you for that. The usage for just simple queries, I mean, I went way over myself and I did even more than I was supposed to. And in 1 month, we arrived at 100 euros once. And that was the
So
maximum.
the price is per query?
Yes, and it's per terabyte.
Per terabyte of scan?
Yes.
Thank you.
Other questions? Okay, super. So thank you again, Daniela,